Okay, guys, today we are doing exponential functions word problems. So we are doing the formula for exponential growth and decay. The only difference between growth and decay is one has a plus sign, the other one is a minus sign. Remember, if it is growth, your b value, your 1 plus r, is going to be greater than 1. If it is decay, your 1 minus r is going to be less than 1, but greater than 0. So we're just identifying all of our variables and then writing our equations and finding what we are asking for. So in the first one, we have Sally Mae just found out that in 1800, one of her ancestors invested $300 in a savings account that paid 4% interest annually. Find the account balance after the year 1950. So it says P is the initial amount, which is the amount that we're starting with. So we have $300 that she's starting with. The rate is 4%. Remember, you always need this in a decimal. So I'm going to write here next to it, we want this number always in a decimal. So 4% is 0.04. And then T is your time in years. So we want to know from 1800 to 1950. So I'm just going to subtract 1950 minus 1800. It's 150 years. So my equation is A equals, and here we're investing, so we know we're growing. So I'm going to have a plus sign. So I have my P, which is 300, times 1 plus my rate, which is 0.04, to the power of 150 years. If I plug that all in to the calculator, I should get $107,676.80. Okay, for number 2, we're talking about the population in California in 1900. It was 1.77 million. So since then, the population has grown. We are adding at a rate of 3% per year. And according to this rate, what is the population in 2000? So we're starting with 1.77 million people, and then we are growing at a rate of 3%, which our decimal is 0.03. And then we need from 2000 to from 1900 to 2000, that is 100 years. So from 2000, so we have 100 years. So we have A equals, my starting is 1.77, and then I have 1 plus 0.03 to the power of 100. And so after 100 years, our population is going to grow to 34.02. Remember, it's in million people, okay? We're going to go to question number 3. So suppose that the acreage of a forest is decreasing. We're decreasing, so that means subtracting, by 4% every year because of development. If there are currently 6 million acres of forest, determine the amount of forest left after 15 years. So I'm starting with 6 million. My rate, it's decreasing by 4%, so it's going to be 0.04. And my time is after 15 years. So I'm going to write my equation. We have A equals my starting value, which is 6 million, times 1 minus 0.04 to the power of 15. If I plug this number into the calculator, we are decreasing our acreage by almost half. I get 3,252,518. That's acres. Okay. The last example on this page, we're just going to be, again, identifying each variable. So $55,000 purchase, that's my starting value. Depreciates, I'm depreciating, so it's minus 16%. I need a decimal, which is 0.16. and after 10 years. So my equation is A equals 55,000 times 1 minus 0.16 to the power of 10. After you plug that into the calculator, you should get $9,619.57. Okay, so now we're going to flip this over to the back. So here we're using the population of Boomtown is 475,000. It's increasing at a rate of 3.75% each year. So when will the population exceed 1 million people to the nearest year? So this one, guys, we're just going to write our formula. So we always start with y equals, my starting rate is 475,000 times 1, we're increasing, so it's plus 3.75. Remember, this is changed to a decimal, 0.0375. 0.0375 to the power of, we don't know how many years, so we always leave it to the power of x. So for this, I'm going to share my screen with you guys. And we're going to use the calculator for this portion. So we just wrote down that equation. So we're just going to enter it into the graph. 475,000 times 1 plus 0.0375 to the power of x. Oops, what did I do wrong? Oh, I did a comma. We can't do commas. Okay. So, and then you're going to go menu. You can't see your graph right now, so you need to fit it to the screen. And then you're just going to go to your table. And we want to know for this question when the value will reach, or the population will exceed, go past 1 million people. So let me zoom in on the assignment so y'all can see it. Okay, so we want to know when it will exceed 1 million people. So I'm going to come back over here to my table, and we're just going to look at our values. Here's the years, and here's the population. So we're just going to go all the way until we see it go past 1 million people. So it goes past 1 million people after 21 years. Okay, just as easy as that. So the next one, we're going to do the same thing. So let's look at the next question and let's write our equation. So the population is 123,000. It's decreasing, so I'm subtracting at a rate of 2.375%. So I have 0.02375. And then we want to know when the population of Leavetown will drop below 50,000. So we want to know when it goes below 50,000. So again, I'm just going to write my equation. So I have A equals, or Y, it doesn't matter, 123,000 people times 1 minus my percent as a decimal. And then we don't know what power, so it's just going to be to the power of x. So now I'm going to use my calculator and we're going to plug in this equation. We're going to go back to the home screen graph. We have 123,000, 1 minus 0.02375 to the power of x. Menu, we're going to fit it to the screen so we can see our trend line. And then we're going to go to our table, split screen table. We want to know when it drops below 50,000. So again, we're looking at the years are my x, the population is my y. And it drops below 50,000 after, right here, we can see it is after 38 years. $38 years for 58,000. That's one of my answers. And then the other one, when will it, what will the population of Levittown be after 100 years? So we're going to look for my x value to be 100. So let's scroll all the way down. After 100 years, it's going to be 11,117. We can't have decimals for the number of people. Okay. Let's do number 7. Same kind of thing. We're writing our equation. So we go from 1890 to 1950. So that's 25 years. So we're going to write our equation. A equals, my starting population is 6,250. It is increasing, so we're doing 1 plus my percent, 0.0375 to the power of 25 for after 25 years. Okay, so I'm just going to go ahead and calculate this because I do have my full equation. I do have the years. So 6,250 times 1 plus 0.0375 to the power of 25. So I would get, for this first answer would be 15,000. I'm writing it over here off to the side. 15,688 people. Okay, so and then after 1940s, I'm adding on another, so here would be 10, so that'd be 50 years. So I'm going to do my equation again, 6,250 times 1 plus 0.0375, but this time to the power of 50. I'm going to do Control Z, and I'm just going to change this number here to 50. I get, again, I'm going to write it over here off to the side, 39,380 people. And then for 2003, so here I would be dealing with 113 years. So again, same equation, just now we are changing that exponent to 113. So I'm going to do Control Z. So for 100 to the power of 113, I get 400,439. And there, I wrote it right here off to the side. That was my answer. And when will the population reach 1 million? So again, for that, we could go to my graph. We could write this equation, A equals 6,250 times 1 plus 0.0375 to the power of X. So 6,250 times 1 plus 0.0375 to the power of X. You don't really need to fit it. We just need to see the table. And we want to know when it's going to reach 1 million. It's going to be way down here. We're really at 30,000, 50, 60, 70, 80. Really at 300,000. Oh, there it is. So we get to 1 million after 138 years. Okay. All right, now last one. The last one we're going to do, guys, it's gonna look a little bit different. So we really I don't want to get too much into all of these. I just want you guys to be able to complete the table. So each time Lauren Hill, she's a contestant on a quiz show, each time she answers a question correctly, her winnings double. So she starts off with $1,000. So before she's even answered the first question, she has $1,000. If she answers the first question correctly, she wins $2,000. If she answers the second question correctly, she wins $4,000. Okay, so the third question would be $8,000. The fourth question would be $16,000, and the fifth question would be $32,000. So you completed the table. And so what is the initial amount is 1,000. So from here, I'm not going to do any of the other things because there's one really easy way that I can do all those next 3 by just plugging stuff into the calculator. So let me show you where you go. So go to the home screen. You're going to click on this green grid down at the bottom. Type in an X and then Y for your columns. And you're going to do 0, 1, 2, 3, 4, 5, just like it shows there in your table on your paper. And then you're going to enter your values for each one of those, your y values. 2,000, 4,000, 8,000, 16,000, and 32,000. So from here, you just click one of the other boxes. You're gonna hit menu. You're gonna go to statistics, step calculations, and exponential regression. For the X list, we put X. For the Y list, we called it Y. And then you're just gonna hit okay. So it will calculate for you. So we know we have Y equals A times B to the power of X. This is my equation. So my A value is my starting point. So I would have, so for my, write an equation to represent the table, I would have Y equals 1,000. My B value is 2, so it would just be in parentheses 2. And then we know it's to the power of X. That would just be my equation. So here it's calling this a B value. We know when we were seeing our equations, it says 1 plus R. So this is B, 1 minus R. This is also B. These are just B written out long ways in the parentheses. That's B, okay? So what is the growth factor? So my growth factor, think about this. If this is 2, so if I have, and we're growing, so 1 plus R, right, equals B. So what is B equal to? It's 2. So to find out my growth factor, I would just solve for R. So I would just get R by itself. I'd subtract 1 from both sides. R is going to equal 2 minus 1 is 1. So my growth factor is 1. And then what is the exponent? The exponent is just X. And then how much money will Lauren win on the 10th correct question? So in order to answer this one, we would do our equation 1,000 times 2 to the power of 10. So if we did that, so it'd be 1,000 times 2 to the power of 10. Ooh, on her 10th question, right, she would win $1,024,000. That's pretty good. And on what question will Lauren win 64,000? So again, we would go to our graph and let's go to new graph. So here we would have 1,000 times 2 to the power of X. And we want to look at our table, the menu table split screen, and we want to know on her when she reached 64,000. 64,000 would be here on her 6th question. Okay. Remember to find that percentage, the growth rate percentage, because you are going to need to know how to find it. You just set that number because it's going to tell you maybe your B, it's going to tell you B equals 0.036, maybe. That could be one. And so you're going to need to find it. So I know this is less than 1. If it's less than 1, that means I'm subtracting. So that means it's 1 minus R equals 0.036. And then I'm just going to solve for R, because these are going to be some examples on your homework. This is just a random example. Okay. So if I solve that, I would subtract 1 from both sides. If I did that real quick in my calculator, 0.036 minus 1, that's going to give me negative R equals negative 0.964. And so that means I need to make these both positive because I can't have a negative X or variable. So it'd be R, my rate would be 0.964. And then you would want to change this into a percent because remember my rate is in a percent. So I would just move my decimal 2 places. So I get 96.4% would be my rate, okay, of decrease, my decay rate. So on the homework that is going to ask you some questions like those. If you guys have questions, please send me your questions. Don't just try to figure it out on your own and keep getting them wrong. Don't get frustrated. Okay, if y'all have questions, let me know. Your homework's on Delta Math.